Hi, welcome. Unit 1 of this Pre-Calculus 11 course is on exponents and radicals, and Lesson 1 is on classifying real numbers. So the real numbers are all the numbers that you know. Any number that you can put on a number line, is a real number. And they're divided into smaller groups of that. So the natural numbers is the first and smallest set. They are symbolized with an N. And these are the counting numbers. They are the numbers that you learn when you first learn to count, and they 1, 2, 3, 4, 5, and as far up. The second group of numbers is the whole numbers, and those are basically all of the counting numbers, and then you include 0. Okay, so the natural numbers do not include 0, the whole numbers do. I remember the difference between them is because whole has a 0 or an O in the middle of it, so that's how I remember it. The next group is the integers, and that is everything we have so far, the natural numbers, the whole numbers, and then all the negative versions of them. So negative anything, negative 500, negative 400, up to negative 3, negative 2, negative 1, 0, 1, 2, 3, and then on up as high as you care to go. The next group is what we call the rational numbers. And the rational numbers are defined as, actually, I think it has it up here. The rational numbers are defined as any number that can be written as a fraction, a over b, where a and b are integers. That's what this is saying here. So the rational numbers, which are symbolized with the letter Q, can be written as a fraction, a over b, where a and b are both integers and b is not 0, because of course you cannot write anything that divides by 0. A number you can't divide by 0. Examples of rational numbers would be 1/2, 0.5, those are the same thing, of course. Negative 1/2 is a rational number. Negative 1 over 3, or negative 2.5353553. These are all rational numbers because you can write them as a fraction of integers. The other group that we have is called the irrational numbers. Now, these are non-repeating and non-terminating, so they never end. So those are like pi is an irrational number. The square root of 3 is an irrational number. It's a decimal that goes forever and ever and ever and ever and ever and ever. Okay. It's not all square roots though, because for example, the square root of 9 actually equals 3. So root 9 is just a different representation of 3. So root 9 is a natural number. Okay. It's also a whole number and an integer and a rational number and a real number. Okay. The real numbers are all of the rational and irrational numbers together. So we can do this in a diagram, and this is actually a good diagram. Often textbooks have bad diagrams. So the smallest set, most restrictive set, is the natural numbers. And then we add that the whole numbers includes all of the natural numbers plus the number 0. And then we have the integers, which includes all the whole numbers and all the natural numbers. And then we have the rational numbers here. And then we have the irrational numbers outside of that. Um, so every real number is either rational or irrational. And we don't have any subsets for the irrational numbers. This over here is really important. The area of each region has no relation to the number of members of the set. Like this space here between the W and the N, there's only one number that is a whole number but not a natural number, and that is the number 0. There's actually, even though actually everything from, they're all infinite sets actually, but there are more irrational numbers than there are rational numbers, even though from the drawing you wouldn't think that, but it just doesn't make sense to draw the picture any other way. Okay. All right, let's do an example of this. So for each of the following, write all the sets of numbers to which the given number belongs. Write the answers from the largest set to the smallest set. So, and we'll just use the abbreviation. So 9, the number 9, it is a real number. It is a rational number. It's an integer. It's a whole number, and it's a natural number. So that one belongs, that's as many sets as it can belong to. 11 over 7, it's a real number. It is rational, but it's not an integer. It's not a whole number, and it's not a natural number. Root 5 is a real number. Like I said, they're all going to be real numbers. There's actually a set of numbers called the imaginary numbers or the complex numbers, but we don't look at those in high school at all. But just so you know, there is something other than real numbers. And then this is irrational, so that is the Q bar. Okay? And -7, that is real. It is rational, and it is an integer. But since it's negative, it's not whole or a natural number. And this question, explain why 9 belongs to 5 number sets, but -9 belongs to only 3 number sets. This is a dumb question. How do you explain why it does? 9 is real, rational, integer, whole, and natural. But -9 is only real, rational, integer, and it's not whole or natural. So that's why there's only 3 sets for that one. All right, there you go. Go and do assignments, questions number 1 to 7, and then go to the next video. Bye.